And welcome back to Making Electronics. In the last episode of the Using Transistors series, we looked at how to design a transistor switch using bipolar NPN transistors such as the 2N3904. In this episode, we'll create an actual design for a switch, build it, and test it to see how well it works. The circuit we used last time had a 100 milliamp lamp as the device being switched on and off. For this circuit, I'll be using an LED with a 221 ohm resistor as the load. As we saw in the last video, transistor switches are used with the transistor in saturation, which means it's basically a closed switch with a small voltage drop across it. This means we can easily determine the current through the transistor by looking at the voltages and resistances in the load circuit. For this circuit, I'll be using a power supply voltage of 8 volts and an LED with a forward voltage of about 1.8 volts. For the 2N3904 transistor, the maximum voltage between the collector and emitter is 0.2 volts. So, given this information, we can calculate the collector current by determining the voltage across the resistor. We subtract the voltage drop across the LED and the voltage drop across the transistor from the power supply voltage and then divide by the value of the resistor. This results in collector current through the transistor of about 27 milliamps, which is plenty of current to light the LED. We can figure out how much base current is needed to switch the transistor on. In the last video, we learned that the collector current is equal to the base current times beta. Beta for the 2N3904 transistor is around 100. So the base current can be found by dividing the collector current by beta. In this case, that gives a base current of about 0.27 milliamps. We also learned that beta is not a stable parameter to use for designs. A good rule of thumb is to set the base current at least 10 times higher to give plenty of margin to ensure the transistor is fully switched on. Using that rule of thumb would set the base current to about 3 milliamps. For this circuit, I'm going to use a 1 kilo ohm base resistor. Since the base to emitter voltage for the 2N3904 is about 0.6 volts, we can calculate the base current by subtracting 0.6 volts from the 8 volt power supply voltage and dividing by the base resistor. That gives a base current of about 7 milliamps. A bit more than is needed, and if I was running this circuit from a battery, I'd probably want to reduce the base current closer to 3 milliamps. In future videos, we'll learn about field effect transistors, which can use much smaller input currents. Now, let's take a look at building the actual circuit. Again, I'm using the 2N3904 transistor, and the pins from left to right are the emitter, the base, and the collector. You can see all the parts that I'll be using. I have the LED, the resistor for the LED, and the resistor for the transistor base, along with some connecting wires and pins I'll be using to supply power to the breadboard. I'm using a jumper wire as a switch so I can easily connect the base to positive voltage or disconnect it. I'll go ahead and apply power to the circuit. My power supply is set to 8 volts. The black clip is ground and I'm connecting that to the bottom of the circuit, and the red clip is plus 8 volts, which I'm connecting at the top. And now you can see when I apply a positive voltage to the base of the transistor, the LED turns on. And when I remove that voltage, the LED turns off. Now I'll take some voltage measurements on the circuit. Here I am measuring the power supply to the circuit. As you can see, it's approximately 8 volts. Now I'm measuring the LED side of the resistor. You can see it's 2.39 volts. This means there are about 5.6 volts across the resistor. Assuming the resistor is 221 ohms, then this results in about 25 milliamps. Based on what we saw from the schematic, this is what we would expect. Now I'll measure the base voltage. You can see it's about 0.8 volts. This is a little higher than what I would expect, but it's within the range of values that you might see. The base voltage is another of those parameters that aren't very stable. It changes with temperature, changes with the type of transistor, which is another reason why you would like to use more than the calculated base current to drive the transistor to ensure it's fully saturated. And now measuring the collector to emitter voltage, you can see it's very low. It's less than 0.05 volts. The value given in the data sheet, 0.2 volts, is the maximum voltage you would ever see. So you would expect to see something much lower than that typically. And that's what we see here. This is a good thing, as it means there's less resistance in the transistor and less power is being dissipated in the transistor, so you can safely put more current through it. Now I'll measure the actual base current. I'm measuring 7 milliamps, which is exactly what we expected. In measuring the collector current, I see 25 milliamps, which again is what we expect from our calculations. If you enjoyed this video, please hit the like button and subscribe, and thank you for watching. Bye.